one of those to display the output in bytes, kilobytes, or megabytes. On the last page, the default is just kilobytes. If I don't give anything to the free program, it just displays the output in kilobytes. Then the -O option has to do with that buffer and cache line, okay? And the -O switch disables the output of that display. So if you want to omit that correction, just put the -O option. And then there's the -T option to display totals. The -V option you can see down here just displays the version information. But if we go back up here, the other one that's important is the -S option. And what that does is it does this like continuous run of free. Let me show you how that works. Okay, if I do free with like -S5, for instance, this is going to run free every 5 seconds. Now, that might not seem like a big deal, like I could just type free again. It's not that hard to type, right? But the point is, like, you could put this kind of thing in some sort of monitoring script. Like if you were suspecting some program to be consuming memory that runs every night at midnight, well, you can run the little free -S, you know, with 10 or 60 or whatever you want in there to monitor the memory usage when that program starts up to see if it really does eat up memory. That way you don't have to like go into work or go onto your computer at midnight when something runs and check it all out. Okay, so you could just run this into a script, and you can put the output in a file, right, by doing something like free -S5, pipe it into free output or something. Okay, so that would put the output of this command into this file. This file would grow pretty fast if this was something like 5, because every 5 seconds it would add, you know, 4 or 5 lines of text to the file. Something like S of 120 or S of, you know, 240 or something would run every 2 or 4 minutes. Then the output of the size of this file would not be very big comparatively to other things. Okay, so this is how you can monitor the usage on your system. If this number here really was approaching the memory size, and it got up to, you know, 95 to 100% of the memory size, then that's when you would see this number start to grow. All right, this number will always be 0 as long as the amount of main memory that you're using is less than the total that you have. All right, so if you see this number here almost always at or near this number, the total memory usage, you know, if that's at or near the total amount of main memory that you have, then, you know, you should increase your main memory size, because that's just saying you don't have enough main memory on the day-to-day operations. You're always using swap space, and swap space should really be reserved for, you know, very intensive, memory-intensive programs that don't happen regularly on your system. Okay, so that's something you have to decide. If you have the room and you have the money to add main memory, and this number is always approaching this total, then you should add main memory to your system. And you know, the swap space can stay where it is. If you add a small amount of main memory, if you like double your main memory, then you should think about increasing the swap space. Okay, and you know, if it's to the point where, you know, the swap space is almost all filled up, and you need to increase the swap space just to keep things running, then I'll show you right now a stopgap measure you can take to increase the swap space just to keep things running. And then we'll talk about like a more long-term solution to this. So if you're really running out of swap space to the point that you need to add some just to keep your system running, you're going to add what we call a swap file. Now, typically, when we talk about swap space, we're talking about swap partitions. Right when we installed our system, we set aside some partition on the disk just to be swap space. And that partition is efficient in transferring stuff back and forth to memory because it's all contiguous. It's all right next to each other. Now, the swap file that we create, you know, that's going to be, you know, it could be really big, but it's going to be spread around in different chunks on the disk. And it's not going to be nearly as efficient to transfer stuff to and from memory. All right? But it will be an okay stopgap measure just to keep your system running. But long term, you should be thinking about adding a hard disk to your system with a big fat swap partition on it, and adding some more main memory while you're at it, just to increase the overall memory capacity of your computer. All right? So let me show you how to add a swap file to your system. You got to be the root user to do this, so I'll do that. And now what you're going to do is you're going to create an empty swap file. And the way that you can create an empty swap file is with the dd command. The dd command just basically takes one file and converts it into another file and changes the size and so on. So what I'm going to do here is I'm going to specify an input file for dd of /dev/0. And what this does is the dev0 device is really, it's just a bogus device that outputs zeros. So when I write this to some other file, that file is just going to be empty. It's going to be filled with zeros. All right, and now the output file, I'll specify that, and you know, I'll just put it in the root directory and I'll call it swap file. All right, and now what you do is you give the block size that you want to create. So I'm going to create block size of 1024, which is like 1 kilobyte blocks. And then you give the count of the number of blocks that you want to create. Now, if you're doing this, say you want to add like 256 megabytes of swap space, then this number here would be like 262, 154, something like that. If you wanted to add 128 megabytes, it would be half that number. And if you multiply this by this, you'll get 256 megabytes, the number that is 256 megabytes. All right, so I don't want to add this much swap file to my system just because I'm showing you for demonstration purposes. I don't really need it. So instead what I'll do is I'll have a count of 1024. 1024 times 1024 is like 2 to the 20th power, which is like 1 megabyte. Okay, so this is like 1 megabyte of swap space that I'm going to add, and it's going to be in this file called swap file. Okay, now I do that, and it says, this many records in, this many records out. And now what I'm going to do is I need to turn that swap file that I've created in the root directory up there. I'm going to make it active. So I do that by saying make swap / swap file, something like that. Okay, now it says it's set it up, swap version, and it tells you how many bytes it is. And then what you do is you say swap on, and then you say swap file. Now the swap space will be activated. So I do this, let me do the free command again, and you'll see now that the total here is 523, 120. It used to be 522 something or other. So what I'll do here now is I'll just say swap off that swap file, and this will make it unactive. Okay, and now let me do a free again, and you can see now that we're back to that 522, 104. All right, so this is what happened now. I created the swap file with the dd command. I made it active with the make swap command and the swap on command. And then you could see it increased. It was already effective. And then to turn it off, I said swap off. And now that space is reclaimed, and it will be used for something else on my disk. Now, I just want you to be aware that this swap file that we just created and activated is not going to be active the next time your system boots up, because you're going to have to do the make swap and the swap on commands again to make it active the next time your system boots up. Now, if you want it to automatically be active every time your system boots up because you're going to keep this around for a while, then you need to put an entry in the /etc/fs tab file, the file system table file that we looked at when we were talking about the network file system, NFS. Okay, now you would put an entry in there, and then it would be active every time. You would designate it as a swap file and so on, and it would be active as a swap file every time your system boots up. But really, you should be looking at either buying a new hard disk to increase the amount of partition space that you have, or if your hard disk is really large and you just underestimated how much swap space you would need, then what you can do is you can repartition your disk. And this is a really tricky task, and there's some programs out there, there's some software out there that'll do it. Check on the news groups and find out what people are using right now. The thing I've heard about is Partition Magic. That's a program that you can use to do it. This is certainly a program, if you're going to repartition your hard disk, that's certainly a program that I wouldn't mind spending some money on, because it's a really tricky thing, and you don't want to have all your files get wiped out and stuff. And no matter what, no matter how well respected the program is, if you're going to repartition your disk, do a full backup and get everything saved, so that if everything does kind of crap out on you, then you've got some backup and you can restore all those files and at least come back to where you were. All right, so we've seen the free command that told us about memory usage and swap space usage. The df command is kind of the counterpart to the free command, and we learned about this several videos ago. This command tells you about disk space, how much for each partition, how much disk space there is, how much is used, and how much is available. And then there's this use percentage column over here that's kind of like the quick and dirty percentages of how much is used on each partition. All right, and when you see this number reach 85, 90%, then you know it's time to get a new disk. But again, as a stopgap measure, what you can do is go around and delete some unused files. And some really big files that often sit around unused are called core files, C-O-R-E. These core files, also called core dumps, are basically, they're the result of program crashes. And when a program crashes, what happens is a snapshot of memory is taken, and that snapshot is put into this file called a core file. Now, a lot of times, like I said, these things sit around unused, but don't just go around and delete them recklessly, because some people use them to figure out why the program crashed, what line of code it crashed on, what the circumstances in the system are that made it crash. right? And so they're invaluable pieces of evidence to these people that are trying to track down problems. So don't just go around and delete them recklessly. But if you see them and they haven't been touched or looked at for a while, then what you should do is try and track down who owns it. So look at the ownership by doing like an ls-l on it.